Okay, in this video, we are going to be looking at discrete and continuous as it relates to domain and range. Okay, so we're going to start with Myra's trip home and Charlie's savings just to get a clear understanding about what discrete and continuous are. So if we look and at the two different situations, you can see we have Myra's trip home. Myra is starting at 450 miles away from home, and then she is traveling closer to home, and in 7.5 hours she is at 0 miles away from home, indicating that she has arrived at home. This is considered a continuous relationship. It is considered continuous because Myra can be 450 miles away from home, but she also can be 449.8 miles away from home. She never stops. There's no specific values as she is heading home. Her miles away from home is always continuing. There's no skipping in between. So now let's look at Charlie's savings. Charlie's savings is considered discrete. This is a discrete relationship because Charlie is starting with $50 in his bank account. And then after 1 week, he has $70. And after 2 weeks, he has $90. After 3 weeks, he has $110. He's clearly increasing by $20 each week. Charlie will never have, according to this graph, he will never have $60 in his bank account. He has these specific values and nothing in between. There's still a beginning, there's still an end, just like continuous, but in this case, there's specific values in between that beginning and end. So this is considered a discrete relationship. Let's go to the next two. So we have Jenny rides her bike 12 miles per hour on a trail in the park. The trail is 18 miles long. The function f can be used to determine the number of miles biked after t hours. And then we have Lexi received a $45 gift card to download music for her MP3 player. Each song costs $150. The amount left on the gift card is a function of the number of songs purchased. So we need to think about both of these situations and think about when we are to graph these, how that they would look. So if we have Jenny rides her bike 12 miles per hour on a trail in the park, the trail is 18 miles long. So that means she's beginning at 0 miles, and she's going to ride a full 18 miles. And I'm going to kind of just sketch a graph. So the trail is 18 miles. Okay, so we know that she is going to end at 18 miles. And so here on my x-axis, I have my time. And on my y-axis, I have my miles. So if we think of the situation, if she's riding 12 miles per hour, at 0 hours, she's going to be at 0 miles. At 1 hour, she's going to be at 12 miles. So let's just go up. We have 6, 12, 18. So at 1 hour, she's at 12. And at 2 hours, we know that she would actually be at 24, which is actually too much. So we have at an hour and a half, she's going to be at 18. Now the question is she going to be in between all of these? Or is she going to be at 0 miles and then all of a sudden she's going to be at 12 miles and all of a sudden she's going to be at 18? Hopefully you're saying no. Hopefully you're saying she's going to have a continuing relationship. And this is, sorry, this is a little crooked. Fix this. hopefully you're saying she's going to have a continuous relationship here. And that means we need to connect our relationship with a line. So this would be a continuous relationship. Now let's look at Lexi. Let's think about how we would graph Lexi. So Lexi received a $45 gift card, and she's going to purchase songs. So let's say this is the number of songs she's going to purchase. And this is her gift card. So this is the amount on her gift card. She's starting with $45. And then she's going to purchase a song at $1.50. So if she's starting at $45 and she spends $1.50, now she has $43.50 left on her card. So we're going to put this somewhere here, and we're going to have $43.50. And then she's going to purchase another song, and now she's going to have 40, 40, let's see, take another $1.50, $42 left on her card. Now this is going to keep going until she has no money left on her card. Now, is she ever going to have something in between $45 and $43.50? Is it possible? Can I connect this with a line? The answer, hopefully you're saying no, this is actually a discrete relationship because she will never have any of those in between. So because she'll never have those in between values, that makes this a discrete relationship. There's a beginning and an end, just like continuous, except in this case, there's specific values between that beginning and end. Okay, let's look at our last two examples. So we are just given an equation of a line. It says the line 2x plus 3y equals 6. So it's clearly just telling me that this is a line. It tells me nothing about specific values or anything like this. But this would actually be considered a continuous relationship. This one actually has no clear beginning or end, and it also has given us no specific values. Now let's look at our other line, equation of a line. It says y equals negative 5x plus 3 for all positive even numbers less or equal to 12. This is very specific for all positive even numbers less or equal to 12. Because this is so specific, it is actually telling me what my domain is. My domain actually, we'll go ahead and put that down, is 2, 4, 6, 8, 10, and 12. There is no in between values for my domain, meaning I could not actually connect my points with the line at specific values. So this is a discrete relationship. Okay, so we're going to go back and we're going to write the domain and range for each of our discrete and continuous relationships so we can actually clearly see what the difference is between writing a continuous relationship and a discrete. So looking back at our graphs, for this continuous relationship, my domain, looking at all my x values, begins at 0 and ends at 7.5. So to write my domain, I'm going to have my least x value, which is 0. 0 is less than or equal to all my x values. And all my x values are less than or equal to 7.5. Okay, so now we're going to look at my range. My range begins at 0, or I'm sorry, the least value is 0, and my max is 450. So to write my range, I will have 0 is less than or equal to all my y values, And all my y values are less than or equal to 450. Okay, looking at Charlie's savings, my domain is all of my x values. And since it's discrete, they're very specific values. So I have 0, I have 1, 2, 3, 4, and 5. And my range is all of my y values. And in this case, if I look at my specific y values, I start with 50, and then I gain another $20, so 70, 90, 110, 130, and 150. So you can see in my continuous relationships, I have the use of inequality symbols to describe all of the in-betweens in that relationship. And in discrete relationship, I just have the specific values to describe that we only have specific values on that graph. Okay, so let's look at our next two examples. So I have Jenny rides her bike 12 miles per hour on a trail in the park, and the trail is 18 miles long. So my domain is my time. So we know that my least amount of time will be 0 hours. 0 is less than or equal to all my x values. And my max amount of time, because she's only riding 18 miles, is an hour and a half. That's how long it'll take her to ride 18 miles. So I'm going to have less than or equal to 1.5. My range is all my y values. So we're looking at this case, the miles that she is riding. So she's going to begin at 0. So 0 is less than or equal to y. And the furthest she's going to ride is 18 miles. So y is less than or equal to 18. Okay, moving on to Lexi and her songs. So Lexi's going to have her $45 gift card. And she's going to spend money off that gift card, and she's going to purchase songs. So my domain is going to be the number of songs that she buys. So she can buy 0 songs, 1 song, 2 songs, 3 songs. You can actually buy enough songs to get up to $45. So that is actually 30 songs. So to save me from writing all of that, I'm just going to hit dot, I'm going to put dot, 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 30. And then my range, we know she's going to start with 45, and then she's going to end, or she's going to go to 43.50. Then she's going to have $42. And we can keep going, but we're just going to say dot, 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 0. Eventually, she's going to have $0 left on that card. Okay, our last relationship. So we have a line, the domain. If I'm looking as 2x plus 3y equals 6, a continuous relationship. I don't know a beginning or an end. It tells me no specific start or no specific end. So my domain, we're actually going to say is all real numbers. My range, again, we don't know a specific beginning or a specific end. So again, we're going to write all real numbers. And my last example, we already wrote the domain for. It's all positive even numbers less than or equal to 12, 2, 4, 6, 8, and 12. And now that's my x value, so I have to solve for my y value. So I have negative 5 times 2. So if my x value is 2 plus 3, this is going to give me my y value. So negative 10 plus 3 is negative 7. And then I'll do it again. I'll have negative 5 times 4 plus 3. So negative 20 plus 3 is negative 17. And I'm seeing a pattern. We're going to decrease by 10. So I'll have negative 27, negative 37, negative 47, and negative 57. Okay, so hopefully in this video you now can explain the difference between continuous and discrete, and you can also tell the difference on how to write the domain and range of those.